When we analyze pile foundations, one of the most important aspects we need to consider is settlement. While individual piles might show minimal settlement, pile groups often experience significantly more settlement. This is due to the way stress is distributed throughout the soil mass below the group. The equivalent footing concept, illustrated in Figure 7-44, provides a practical method to analyze this group settlement behavior. This concept was originally proposed by Terzaghi and Peck in 1967 and has since become a fundamental approach in foundation engineering. So, what exactly is the equivalent footing concept? Essentially, it models a pile group as if it were a single, large footing situated at a specific depth above the pile toe. For a group consisting of only vertical piles, this equivalent footing has a plan area that corresponds to the perimeter dimensions of the pile group, defined as width b times length c. The equivalent footing is typically positioned at a depth of 1/3 of the pile length above the pile toe. This location represents the theoretical point where the pile group's load is effectively transferred to the underlying soil mass. The pile group load, spread over this plan area, represents the stress transferred to the soil through this equivalent footing. From this equivalent footing, the load is assumed to spread within what's called the frustum of a pyramid, with side slopes at 30-degree angles. This distribution causes a uniform additional vertical stress at lower levels in the soil. The stress at any given depth is calculated as the load carried by the group divided by the plan area of the base of the frustum at that depth. This approach allows us to estimate settlement by considering the following: the pile group's geometry, the soil layers below the equivalent footing, the stress increase in those layers, and the resulting compression of the soil. What makes this concept particularly useful is that it allows us to apply conventional settlement analysis methods to what is otherwise a complex soil structure interaction problem. Instead of analyzing individual pile soil interactions, we can treat the entire group as a single unit affecting a defined soil mass.